Measure units after the division.
Thank you, Sebastian. So this table right here shows the number of people that have entered after so many minutes. So what do you think T stands for? Yeah, T stands for time. And it's being measured in minutes. I'm just going to abbreviate that. T stands for time, and it's being measured in minutes. Okay. What are we measuring? What are we counting? What's being counted? Say that louder. Yeah, this is the number of people. So that N of T just represents the number of people. Okay. So we're going to look at the two intervals, and it's going to be represented as a function. So this is just saying, hey, tell me what the value of N of 9 is minus N of 4. So this just means let T equal 9. So let's go look at our table when T equals 9. When T equals 9, what is N of T? It's 102. So I have 102 minus, when N equals 4, or when N of T is 4, so T is 4, my N of T value is 32. What does 102 minus 32 equal? 70. So the question says, what does this represent in the context of the problem? What does this represent in the context of the problem? So that N of something represents the number of what? Number of people. So that means that 70 people entered the theater. And what was our interval? Over what interval of time? In a 5-minute period. In 5 minutes, what is the time that we're measuring? From what time to what time? Yeah. From 4 minutes to 9 minutes. That's what it means in terms of the problem. And I'm going to write down what Hayden said. That's 5 minutes. In 5 minutes, 70 people entered the theater. So question B, I'm going to wait a second for everybody. I have filled out notes up there that I have not passed out. I'm going to grab them and pass them. Okay. So question B is going to ask us to think of this in terms of a rate of change. Think of this in terms of a rate of change. So at what rate did people enter the theater from T equals 4 to T equals 9 minutes, and show how you found this and use per in your answer. So we know that between 4 and 9 minutes, 70 people entered. And that 4 minutes to 9 minutes is how many minutes passed? Well, Hayden told us that was in 5 minutes. And this is just going to be a rate. This is a rate. We want to write it in the most simplified form. So how can I simplify 70 people every 5 minutes? Could I get a how many people each minute or per minute? How would I do that? Yeah, what is 70 divided by 5? Yeah, good job. So that means that there's 14 people per minute. That's the average rate of change during that time interval. 14 people per minute. Raise your hand if you need more time. All right. So on average, were people entering the theater faster between 4 and 9 minutes or between 9 and 15 minutes? So that first question, A and B, taught us how to find the average rate of change. And now we're going to do it like kind of quickly, not all at once. Well, we know that the interval between 4 and 9 minutes, how many people entered? 70 in a 5-minute interval, or 14 people per minute, right? We already discovered that. Can we figure out how many people entered per minute in the 9 to 15 minute interval? Well, let's figure out the n of 15 minus the n of 9. So look at your table. How many people entered at the 15-minute mark? Look at your table of values. I didn't hear you. Yeah, 150. Minus how many people had entered at 9 minutes? 102 over 15 minus 9 is how many minutes? So let's simplify that. What is 150 minus 102? And what is 15 minus 9? 48. Good job. And 6. What is 48 over 6? It's 8. That means 8 people per minute. So which one had people entering at a faster rate? The 4 to 9 minute interval or the 9 to 15 minute interval? Yeah, people were entering faster at the 4 to 9 minute interval. They were entering faster at the 4 to 9 minute interval. Does this make sense? So we're really just calculating slope, and the ordered pairs that we're getting come from the intervals. Okay. So for the linear function, choose two values to show that the average rate of change is the same thing as slope. The average rate of change is the same thing as slope. So we're proving that the average rate of change is the slope, that they have the same value. So I want you to grab your calculator, everybody. And you're going to go to y equals. Go to y equals. Remember, your y equals button is right here. It's the first button. You're going to press y equals, and you're going to type in 5x plus 2. Y equals 5x plus 2. So to clear it, you do second quit, and then go to y equals. Okay. So if you need to clear, if it's in a table already, if you guys hit the second button, if you hit your second button and then mode, that quits wherever you are and puts you right back to the calculator. And then you can hit y equals. Does everybody see the y equal button? Okay, so y equals, you're going to type in that equation, 5x plus 2, or that expression. 5x, where's your x? So here's x button right here. X plus 2. Okay, 5x plus 2. If you need help, raise your hands. Okay, once you input that equation in y equals, I want you to go to the table. Do you remember how to get to the table? So y equals, they're in that green, that blue basket up there. So y equals, we're gonna hit clear, and I want you to do 5x, this is an x button right there, plus 2. And then I want you to hit second graph. Do you see how that says the word table? That gets you to your table. After you put in your equation, you do second graph. That gets you to your table. Second graph. Second graph. I want you to look at your table of values. And let's just pick 2 ordered pairs from your table. I don't care what 2 ordered pairs you pick. You're right. Give me 1 ordered pair. 22 and 112. That means that when X is 22, Y is 112. I need someone else to give me an ordered pair. Anyone. Someone try to give me a negative one. Give me a negative number. -3. When X is -3, who said that? What's the output, Jaden? -1. When X is -3, can I see your calculator for a second? You want to do this. Look, after you want to hit second table. That way you can pick a point, okay? When X is -3, what's my output? -13. Okay. So we're going to calculate the slope. This is my X and my Y coordinate of the first ordered pair. This is my X and my Y coordinate of the second ordered pair. Y2, -13, minus Y1, 112, over X2, -3, minus X1, 22. So what is -13 minus 112? Are the signs the same or are they different? Are the signs of these two numbers the same or are they different? They're the same. So I'm just going to add them together and keep the sign. 112 and 13 equal 125, and it's negative. What about -3 and -22? Are the signs the same or are they different? They're the same. So add those together. 3 and 22 is 25. Keep the sign. What is -125 divided by -25? It's 5. M equals 5. The equation that you input into your calculator was y equals 5x plus 2. Does the average rate of change that we just discovered match the slope in the equation? Yeah. So I told you at the beginning of the lesson that average rate of change is slope. Now we just proved it. Okay? So don't let average rate of change confuse you. It's just slope. Questions? Okay, turn the page. All right. So we're going to talk about graphs of lines. We're talking about graphs of lines. Oh, we've already done that. Hang on a second. I need to get to the right spot. We're talking about linear modeling, and we're only going to do 2 of these examples. We're only going to do 2 linear modeling. So when I say modeling, what does that typically like when we say we're going to model something or we use the word application? What does that mean? That's code for what kind of problem? Code for a word problem, right? You guys love word problems. So when we see modeling or application, that means we're going to do a word problem. So Dia was driving away from New York City. She was driving away from New York City at a constant speed of 58 miles per hour. He started 45 miles away. We need to write a linear function that gives Dia's distance from New York City as a function of the number of hours. So we're really going to write an equation that looks like this, y equals mx plus b. And once we write that equation, we're going to replace the y with d of h equals h times x plus b. And I know that looks scary, but let's just write it in the form we know, slope intercept, and then we'll do that translation, okay? So how far away am I from the city when I start? Yeah, that's my b value. That's my starting or initial value. Or sometimes it might say beginning fee. Those are all the ways that B can be represented in a word problem. Starting, initial value, or sometimes it says beginning fee. Those are the words that represent the variable B. So I know that B is going to equal what value? How far away was I from the city when I started, Seamus? 45. Thank you. 45. B is 45. Okay. Let's think about our speed. Our speed is our rate. Our speed is our rate. And we just learned that our rate, the word rate, means the same thing as what? Slope. Okay. So what is our rate, which is our slope? What is that value? 58. So I'm going to write a little note up here that tells us about slope. When I'm looking for the word slope, slope often appears as the word rate, or it'll have a per, or each, or every. The number that represents slope is always going to be right next to the word rate, per, each, or every. And I shouldn't say always, but 90% of the time at least. Okay. So those are indicators, those are words that help you identify slope. So do we have everything that we need to write an equation in y equals mx plus b? Yeah, we do. Let's see. Y equals, what did you say our slope was? Or our rate? 58 x plus, oh, what is our b value? Sorry, 58x plus 45. So d of h equals 58. And instead of h, we're going to, or x, we're going to use h plus 45. This is the way that the problem wants us to write it. This is the way that we like to write it. Are either one of these different, or do they really mean the same thing? They mean the same thing. So if you were to write an equation in slope-intercept form, this one up top that I've kind of got highlighted in the yellow box, and you were doing a multiple choice question, would you be able to identify the function that looked similar if you knew that you were using D and H? Does it make sense how we just translate those variables? Okay. So I'm going to scrunch that up a little bit and move over to example B. So if Dia's destination is 270 miles away, meaning that my distance is 270 miles away, what variable is representing the distance? Y. I heard both. Y and the D of H. Yeah, that's the distance. How far away is this person? Whoops. Dia is how far away from the city? 270 miles. So instead of telling you how many hours they drove, they're telling you how far away they are, and you have to figure out how long it's going to take them. So they're going to give you the Y value, and you have to calculate the X, meaning they're giving you the output. You have to find the input. How am I going to do that? I'm going to write this equation for you to look at. Y equals 58x plus 45. You just told me that Y equals what? Okay, so how can I solve for how long it will take, the number of hours? How can I solve that? Perfect. 270 equals 58x plus 45. Keep going, Noah. That's perfect. What would you do to get perfect? So 270 minus 245 is 225 equals 58x. Then what would you do, Noah? Yeah, divide both sides by 58. Outstanding. Divide both sides by 58. Okay. So when I divide 225 by 58, I find out that x, which is really representing the number of hours, so I could also use the variable h. How many hours is that? About, if I had to do it to the nearest tenth. It says to the nearest tenth, which is 1 decimal place. What do you get when you take 225 divided by 58? Here's our math right here. 225 divided by 58. So it's, when you put it in your calculator, what do you get? 3 point what? 3.87. I think I got 3.7. Oh yeah, 3.87. You're right. You're right. I'm so sorry. 3.87. But it asks us, and it goes on forever. 3.87, blah, 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 right? It asks us to round it to the nearest tenth. The tenth is 1 decimal place. So I can only have 1 decimal after that number. What does that mean I have to do? Change the 8 to a 9. So it's about 3.9 hours. It would take us about 3.9 hours to drive 270 miles at a constant rate of 58 miles per hour. Okay. Are we good with that? Okay, I'm going to leave that there for a second. We're going to do example number 11, and then we're going to be done. Example number 11, and then we're going to be done. Raise your hand if you're still working on that exercise 10 and you need more time. Okay. I need someone to read exercise 11. Someone to read exercise 11.
She noted as a fixed cost per month, one of the 15-cent charge for cost.
Perfect. Thank you so much, Raya. So fixed cost. What does fixed cost represent? Does that it represents B? Good job. So this fixed cost is B. We don't know what it is, but we just know it represents B. Okay. What is our per call, that charge per call representing? Is it representing the X or it is 0.15? Do you guys see that word per? What did I say about the word per? What does per represent? It represents your M value. Yeah. This is your slope. Okay. This $12.80 for 52 calls. This is an ordered pair. This is an ordered pair. X is the number of calls. Y is the total bill. X is the number of calls. Y is the total bill. Does that make sense? Yeah. Okay. So it says to create a model, a linear model, meaning we're going to write an equation and we're going to write it in point slope form. So if I want to write something in point slope form, that means I need to have some ordered pair and I need to know slope. Do I have some ordered pair given to me in the word problem and do I know the slope? Yeah. What's the ordered pair that's given to me? Yeah, 52 and 12.8. So the ordered pair is 52. That's my X value, comma, 12.8. I'm not going to carry that 0. I don't need it. And what did we say our slope was? What is that cost per? 15 cents. So 0.15. 0.15. So we're not going to use the P and the C variable. We're going to use our Y variable. Y minus Y1. We're going to do what we know. So how do I write Y? Like, how do I write that equation into point slope form? Tell me what that looks like. Cameron, are you volunteering? Are you stretching? Stretching? Equals M times, I'm catching up, X minus X sub 1. Okay, perfect. Can you substitute in the variable values that you know? What? Do it. I'm ready for you. You want someone else to do it? Why don't you call in someone else? Who'd you pick? Matthew. You ready? Matthew, look. Do you know what the slope is? Okay. Do you know what the Y coordinate is of the ordered pair? Okay. So Y minus the Y coordinate is going to be Y minus, okay, equals the slope, which is what again? Okay. Times X minus, what's the X coordinate of the ordered pair? Sure, you do know how to do that. There you go. It's perfect. That's absolutely perfect. Bailey, you with me? Okay. So the reason we're asked to put it in point slope form is because it wants to find her fixed, it wants us to find that fixed charge, how much she pays for the plan in addition to the cost per minute, right? Or the cost per number of calls. So really what we have to do with this equation is we have to take this equation and put it in what form? Because I need to find B. What form do I put this in if I'm trying to find B? Yeah, good job, you guys. I need to put it in slope intercept form. It is Y equals MX plus B. So we're going to have to take this equation with decimals and solve for Y. That's basically what we're doing. We are solving for Y. What's that going to look like? What should I do first? Distribute. Yeah, I'm going to distribute this. Okay. So I have Y minus 12.8 equals, well, 0.15 times X is 0.15X. I need somebody to use their calculator and take 0.15 times negative 52 and tell me what that is going to be. 0.15 times negative 52. Negative 7.8. Thank you. Okay. So now, what do I do? I'm trying to get Y all by itself. Yeah, good job. Good job. Add the 12.8 to both sides. Add the 12.8 to both sides. So Y equals 1.5X plus $5. So what is my initial fee? Or I think they called it my fixed charge. What is that fixed charge? Yeah, it's $5.